Alright, let's look at a convex mirror and draw the ray tracing diagrams for a convex mirror. We're going to have our object out somewhere beyond the mirror here, and this is the curvature of the mirror. The mirror coating is on this side, and where the image appears to be is going to be on this side. Now, convex mirrors have virtual images because the object is going to appear to be into the mirror. We're going to draw C. This is the center of curvature. The focal point is halfway in between C and the surface of the mirror, so the focal point is here. And our three ray tracing rules are, if a ray of light comes in parallel to the primary axis, it's going to pass to the focal point. Now we're going to look at, first, we're going to look at the reflected ray. If this is a line that is tangent to that point on the mirror, the law of reflection states that the angle of incidence is going to be equal to the angle of reflection. So this is going to reflect that way, and we draw this as the imaginary dotted line that's going to go back and meet toward the focal point. This angle here, if that's the normal to this perpendicular that we drew, perpendicular to the normal but tangent to the curvature of the mirror, theta 1 here is going to be equal to theta 2 there, and we're just going to erase this for now. Alright, now if a beam of light comes in and passes to the focal point, so it's going to be aimed at the focal point here from the top of the object, it's going to come out parallel. So this beam of light is going to come out parallel like that, and it traces a line back that way. And then if any beam of light comes in and strikes the center of curvature, it will reflect back onto itself. So if it strikes this point, it's going to come in this way, but reflect back out that way, and you trace that line through here, and all three lines converge to one point, and this is where the image is actually going to appear. So you would have an image that is virtual, it's into the mirror, it is upright, and it's smaller. This is the kind of mirror that you would see on your vehicle that says objects in the mirror are closer than they appear, because in our minds, things that are smaller than they actually seem to be are further away. And so there's that little warning on the mirror that says that the object is actually closer than it appears to be, so you need to apply your brakes accordingly and be careful when you drive. But back to the ray tracing, you have three rules of ray tracing. Objects or beams of light that come in to the focal point come out parallel, and beams of light that come in parallel to the primary axis reflect back, passing to the focal point, and the center line reflects back onto itself, and the image is formed where those three lines meet.